I'd like to finish up our discussion of average speed and instantaneous speed that we started on Friday. We got cut a little short. If you'd like to follow along in your textbook, this is section 2-1. We're going to talk about examples 1 and 2. This is the PowerPoint we were using on Friday. We said if we drove 200 miles and it took us 4 hours, we could compute our average speed for the trip. So 200 miles divided by 4 hours makes 50 miles per hour. That could help us with our planning, but it doesn't help us to figure out much about how fast we were going at any point on the trip. So we talked about how we could look at our speedometer, or we could have a policeman radar gun us and tell us that at some particular moment our instantaneous speed was, say, 65 miles per hour. So speed at an exact moment in time is instantaneous speed. And that's going to have a different way of computing than the average speed. So here's an example we did. We said if we have a rock that falls from a cliff and we have a formula that tells us the distance the rock falls. Here it's y equals f of t equals 16t squared. We could compute how far the rock has fallen after 2 seconds, for example. So I can plug in 2 for time, square the 2, multiply by 16, and after 2 seconds the rock has fallen 64 feet. I can use that information to compute average speed. After 2 seconds, the rock has fallen 64 feet. It took 2 seconds to fall. 64 feet divided by 2 seconds makes 32 feet per second. That's the average speed of the rock. But again, we know if we had a radar gun trained on the rock, it's not falling at 32 feet per second the whole time. The rock is going to fall slower, and then faster, and then faster, and then faster. We know it accelerates toward the Earth because of gravity. Could we use math to figure out how fast that radar gun would read at exactly 2 seconds? So how can we compute instantaneous velocity at exactly 2 seconds? Well, we still have that same quotient we want to find. The change in distance divided by change in time is still going to give us speed. What's going to change here, though, the thing we're going to change about our computation to find instantaneous speed instead of average speed, is to let the second time value get closer and closer and closer and closer to the first time value. So if I can figure out what the distance fallen at time equals 2 is, and the distance fallen just the teeniest bit later, that's going to help me focus in on the instantaneous speed at exactly 2 seconds. So my f function is 16 times t squared. That tells me the distance the rock has fallen. I'm going to evaluate that function not only at 2, but it also at 2 plus a teeny tiny bit. I'm going to call that teeny tiny bit h. So I have 2 plus h as my second input value, my second time value. So we could use a computer or a calculator to pick small values for h, maybe even smaller and smaller values for h, to figure out what this instantaneous velocity would be. And if you'll remember that word infinitesimal that we used when we first discussed a definition for calculus, getting smaller and smaller, or a teeny tiny change, you can see how it applies here. It's going to show up all semester long, all year long. So here's what happens if we let a calculator do the work for us. There's a table here in blue on the right. You can see that as h gets smaller and smaller and smaller, that quotient we've been trying to find, change in y over change in time, gets closer and closer and closer to 64. So we're going to say that 64 feet per second is the instantaneous velocity of the rock. All right. The problem is, we're not always going to have a computer or a calculator to do this for us. But it turns out we can use algebra. So watch the algebra that we can use to compute instantaneous speed. So the trick here is to pick a variable, I called it h, and let the variable be really small and get closer and closer and closer to 0. So I have my same quotient. I'm going to FOIL out in the numerator, so I'm going to take 2 plus h and square it. I can multiply that 16 through and simplify, and notice now I can factor the h's out and cancel them. At the end, I have that instantaneous velocity is 64 plus 16 times h, but what's h? It's a number that's small and gets closer to 0. So 64 feet per second